Chain rule is the technique we are going to see now in differentiation, but please don't forget to subscribe to the channel. Now, we have seen the basics of differentiation by reducing the power by 1 and then multiplying that power or the power in front of the function. Now, we are going to see that there are some functions which are hard to differentiate when you're using that technique. For example, when they give you such functions and they tell you to differentiate them and get the y dx, so this one is a value of y and t, this one is a value of x and t. To get the y dx, you cannot just use the technique we have seen. Now, this one we are going to employ the chain rule. This is the technique that can be used to differentiate functions of the form y equaling fx power n and y equaling 2 when you have two functions but with the same value. How do you differentiate them? When you have this equal to this and x equal to this, you differentiate this with respect to t and also differentiate this with respect to t. Now to get the y dx, you get the y dt times the t dx. You see that as if this one, as if it's not true, but as if this and this, they cancel and you get the y dx as that. So whenever you have two functions with the same variable, you can always get their derivative as you see that it's combined with them. Let us see some examples here. So origin is to quote this formula origin. So differentiate the following. They give you this and they give you this. So differentiate these two. What we are going to do, we first differentiate y respect to t and also x respect to t. So differentiate this I get the y, the t is going to be, when you differentiate 3t, you get 3. And differentiate a 4, it's a constant, is a 0. So also this one I get now the x, the t, our dx, the t is going to be, when you differentiate 2t, you get 2. When you differentiate a 1, you get a 0. Now to get the y dx, we got our formula. Our dy, dx will be the y, the t times the t dx. So that is that as if the t dx, as if this one goes away and we have y dx. So now our dy dt is 3 now times the t dx. Now such our d here we have the y, the x dt, but we need the t dx, means that we get a reciprocal of this. So the reciprocal of this becomes the t, the x. The reciprocal of 2, we get a half. So that's why I'm coming to that. So times now a half, which will give us 3 over 2. And that will be our there. When you come to this, so now we have y equal to this. Now this one, you see we have to use the power method. So we have to expand this 4 times. We have to expand this bracket 4 times and multiply, which is going to be tedious and time will be vanishing. Is what we do, we let this function inside be any letter, and this one will be that letter power 4. How are we going to do that? So we say, let u be what is inside, which is 4 minus 5x. So after doing that, you start now our y rate will be, now the order of this is u. So u by now to power 4. So now I have this in terms of this, and I also have this in terms of this. So what do? We differentiate now. When I differentiate this, I get the u, the x equaling 2. When I differentiate this, I get 0. When I differentiate this, I get negative 5. What about this one? I get my dy du equaling 2 for u. Then I reduce this power by 1, which will be a 3. Now instead I have the u dx, I have the y du. So now to get what was combining the y and then y and x, which is the y dx, I'll say my y dx will be now the y du times du dx. Now this time I don't need to get the reciprocal. Why? Because here I already have the u dx, which I need here. Here I got the reciprocal because I wanted the t dx since I had the x dt. So here I don't need to get the reciprocal. Now if you substitute there, So that we have now dy du is here as 4u cubed, then times now du dx, which is a negative 5. When I multiply this times this, I get negative 20 u power 3. But now what is our u? Because it wasn't in the question. Our u was this. So now my dy dx is going to be now negative 20 into my u. But my u was 4 minus 5x. Now power 3. So we have differentiated that. Is. So that's how we handle that. Now when I come to this, you see, still this one is going to be a bit hard to expand, or it's going to be long to expand. So what I do, I let this inside the thing be an letter, so let me say let it be t. So let t be 4x squared plus 3. Now if the whole of this is t, it means that my y will be t, then power 5. So now we get the t dx. Dx is going to be, and if this we get, this times this we get 8. Then x, so reduce this power by 1, we get 1. And if this we get 0 because it's a constant. Then y, the t is going to be, we lower the power, which is 5t. And reduce this by 1, we shall be having a 4. So now you have the y dt, you have the t dx. You can combine and get the y. Why? We want now the y dx because they are the two original functions given, variables given. So now my y dx is going to be the y dt times dt dx, which will be the y dt is 5t power 4, then times dt dx. So what I have here, dt dx, which is 8x. 80x. When I multiply this here, I'll be having this and this. I have 40x, then times t power 4. And now my t, I have it here. So now my y dx will be giving me now 40x into now what t is. My t is here, 4x squared plus 3, now power 4. That will be our answer. When I come to this now, it's also tedious. So what I do is that this one is down. So I first take it up. So see this one is the same as 1 over 1 minus x squared power a half. The same, the square root is the same as a half. Now I first take it up. We have now y equal to 2. When I take it up, the sign of the power is going to change from a positive to negative. So if it was negative, to now change to positive. But now this is positive. When I take it up, it's going to become a negative a half. So it's like you can't expand this using what we know of expanding brackets unless you use binomial. But that's our total 1. So let this one be any later. So I say, let u be 1 minus x squared. It means that if u is this, my y is going to be u power negative a half. So when I differentiate this, I get the u dx, which will be negative 2x. This one I'll be having y du equal to negative a half. Lower the power, then reduce the power by 1. Reduce subtract here negative 1. I'll be having negative a half minus 1, which will be negative 3 over 2. So meaning that now our dy dx will be y du times du dx, which will be our dy du is here as negative a half u power negative 3 over 2, then times du dx. Our du dx is negative 2x. Start this to here, cancel with that. So I have negative and negative give me a positive x. Then u power negative 3 over 2. So now from here, my dy, x will be now x into, I know what my u is. My u from here is 1 minus x squared, the whole power now, negative 3 over 2. And that will be the derivative of that. Now, there is a simple technique how you can easily handle this in one step. Look at this alternatively. Now, this is a simplified way of differentiating using chain rule. You see, in number 2, we had y equal to 4 minus 5x power 4. What we do, to get the y dx, you can do this, the y dx. It's similar to the power, but it is something we do after. You lower the power, which shall be having 4 into 4. Maintain this bracket. Then reduce this power by 1, reduce this by 1 and get 3. Now after, here we are adding on something that we didn't add on the power rule. Now here you differentiate this bracket t. So I differentiate now the bracket only. When I differentiate this one here, the function in the bracket. When I differentiate this, when I differentiate this, I get 0. When I differentiate negative 5x, I get negative 5. So this is what we never added in the power rule. So now, when you get this times this, you'll be having negative 20 into 4 minus 5x. Now, power 3. And you would have done that in one step there, as you see. I think this is the answer is the same. Or even here, if you know that property also, you just come number 3, our y will be now 4x squared plus 3, the whole power 5. Can you apply that technique? So to get the y dx, I'll be having y dx as we lower the power, which is 5 into, we maintain this bracket by 3, reduce the power by 1, when I reduce this by 1, I get 4. Now, we differentiate also this bracket. When I differentiate this, differentiate 3, you get 0. When I differentiate 4x squared, you get 8x. 8x. When I differentiate this, now it's at our now y dx will be, now when I multiply this and this, I get 40. Then my x into 4x squared plus 3 power 4. And we have finished that in one step. I think you see the answer there. It's the same. So this is how we apply chain rule in simple terms. When I have that now, number 4, remember the whole of this we said is this, which is y equal to 1 minus x squared power negative half. The same idea. So our dy, the x will be lower the power, I'll be having negative half. Get this power times the bracket, maintain the bracket, reduce this by 1, reduce it by 1 and get negative 3 over 2. Then differentiate the bracket. Differentiate this bracket, you get negative 2x because this will be 0. This we get 2x. Now this negative and this negative, so this 2 and this 2 will cancel. So we shall be having a negative and a negative, which is a positive. Then this will be x into 1 minus x squared power negative 3 over 2. And when you look at this, you see it's the answer we had there. So that's it, members. That's how we can easily use the idea of chain rule in simple terms. I wish you well.